In the first video, I went over the setup with the work coordinate system and the stock and doing the bore operation, which will allow us to hold down the stock material to the fixture plate. And then I copied that for a setup 2, which will be the setup where we will do the actual machining of the parts. Notice there's a check mark here. That's the default folder, so all new operations will go under setup 1. We want them to go under setup 2. So to do that, I can right click and go default folder. So now the check mark is there, and all of our new setups will be in under here, or all of our new operations. Looking at all of these holes, if I do some measurements, if I hit M, I can measure. You can see that's a 0.196 diameter hole. Those are close fit clearance holes for number 10 screws, so that's what all of those are for. There are some smaller holes. Here it's 0.165, and here is 0.165. Those are, I think, holes for the motor mount, and so those are a little bit smaller. But we're going to use the boring operation to do that, and we just need an end mill that's smaller than 0.165 inches. We use the 1/8 inch or 0.125 inch end mill. I'm going to go bore. First thing I'm going to do is tool. We'll select, instead of tool 3, we're going to go to tool 2, which is a 1/8 inch flat end mill. Select that. Then I'm going to select these surfaces here. I can go select holes of the same diameter. We'll get those. I also want more. Okay, so I'm going to select additional holes, and I need to select this because I have a new selection of different size holes. It's going to get all of those. So it looks like it has all of those small holes, the 196 and the 165. The height, we do want to start not with the whole top, because notice we want to make sure that we're starting the bore up above the surface here because there's still material. So instead of whole top, I'm just going to go to model top and bring that up. Also, the bottom height on the whole bottom, we're going to stay above the bottom of the material by 0.003 or 0.003. And then we're going to make it a finer pitch. I just basically define the ramp angle, and 2 degrees will work. It is a little slower. You can see how fine you can go, 3 or 4 degrees. I just don't want something like a 10-degree ramp that is pretty harsh on the end mill coming in that quickly. So I'm going to leave it at 3 degrees. And I think that's it for the boring. So we'll go there. You can see we bore out all of those holes. Next, we're going to clear out these. These are probably for some bearings, and the motor boss, that's the part that sticks out of the motor that will go in these holes. But we're going to clear out all these holes and with an adaptive, and then come back with contour. So I'm going to do that here. I'm going to use a larger end mill. We're going to try a 1/4 inch end mill. And I use the stub end mill. That allows you to machine more quickly. It's more rigid, it's shorter, but it does have enough flute length to be able to machine through 1/4 inch material. So I'm going to select that. I'm going to select the bottom edge here, and here, and here, and here. Basically all of those nice circular holes, and it looks like I need to get this one as well. So I'm going to do that. We have the height. I want to stay above the bottom of the hole by 0.003 of an inch. And we're going to have a radial stock to leave, but make sure you change the axial stock to leave to 0. This could be 10 or 20 thousandths. And let's hit OK. I think we're going to need to change the helical ramp diameter in the linking parameters. And yes, we do, and that's because these were not hit. The reason why they were not hit is the hole is smaller than the helix that allows us to fit it in there. So I'm just going to change that. I usually just do trial and error until I get a hole or a ramp, helical ramp that fits. Looks like everything is fitting there. So now that I have this, I need to come back and clean up that material with a contour. And since these are holes for either bearings or motor bosses, I'm going to do a negative stock to leave and a repeat the finishing passes, which is a spring pass. So I'm going to go here, select this, right click, create derived operation, 2D milling, 2D contour. We're going to do the same tool, the same geometry, the same depth. Basically, I'm going to repeat the finishing passes, so go around twice, and the stock to leave. What we found for bearings is a negative 6/10,000. So notice the 6, you have 0, 0, 0, 6. Common mistakes are people put 6,000s, not 6/10,000s. 6,000s of a radial stock to leave actually makes these holes slightly larger by twice that amount in diameter, so it would be 1.2 thousandths larger in diameter, and we found that that works really well for our bearings. So we're going to go OK, and that cleans those up. So basically what's left is this stuff here, this little step downs here, and then we need to contour out. For those step downs, we can do like a 2D adaptive. Concern there, and let's click these and let's see what happens. You could do a 2D pocket as well, but the concern is the entry, and I'll just show you. We'll have the bottom height just to what I selected. We'll have a radial stock to leave, and we'll hit OK. Challenge is there's no helical entry. It's basically diving into the material, and that concerns me. Diving down 1/8 of an inch into that is not what we want. It's pretty hard on the end mill. So I'm just going to go and select multiple depths. Let's see where that is. We're just going to go multiple depths, maybe break that into 3 steps. So that's 1/8 of an inch, which is 0.125. So if we go like 45 thousandths, let's see what happens. Basically, we break this down into 3 steps. It takes a little longer, but we're basically going just a small depths, and that should give us a better result. Unfortunately, the helix doesn't work, and so we're just going to leave it like that, and we're going to do a slight dive, but we're only diving slightly into the material. So we're going to hit OK, and we got that. One thing we do need to come back is clean this up with a contour. So I'm going to go 2D contour. I'm going to hit the Alt key. I'm going to click Alt and just select this. If I don't select it, there's a good chance it goes all the way around, and I don't want to do that. I'm just cleaning up this edge. So holding the Alt, we go with these. And we're just going to keep the same tool, tool 4. The height is what I selected, and I should be able to just keep, I think, the lead in and leads out as default. Well, it looks like I scrolled and changed that. I'll hit OK and see what happens. See what that looks like. A little concern is that I am diving into material, and that bothers me slightly. So I'm going to go back and change the linking. I'm going to change this to 0 and see where we're at here. I think we're okay here. I think a lot of this already got cleared out. We can look at it through the simulation. Basically, I'm really concerned about just diving in to material to cut this out. We could come back and do this at the very end after the end cutout, as long as we have enough tabs to hold the stock material, or to hold these pieces in place. But we'll come back to that at the end and take a look. Final thing that we want to do is just do a 2D contour and cut these out. And we're going to use the 1/4 inch end mill. I'm going to select the bottom edges here. We are going to have some tabs. Usually I have my tabs at maybe between 3/8 and a 1/2 inch wide. We'll go 375. I do like the triangular tabs. The thickness of the tabs, I think 30 to 40 thousandths is good. I don't want tabs that are too thick. I'll stay at 30 thousandths, and we'll take a look at that. Other thing, The heights we want to stay above by 3 thousandths. We do want a ramp. We're going to ramp here, but the maximum ramp step down, I basically want to slowly ramp as we go down, so not 3/8, so it's going to be, let's try an 1/8 of an inch and see where we're there, or 125 thousandths. And let's take a look at what's happening here. Basically, we're entering, we're slowly winding down, and then we get to the bottom height and leave those tabs. One thing I do want to change is the entry point. Notice how it's leading in here at this 90 degree, and I don't like diving into any material like that, so I'm just going to change that 90 to 0 on the linking parameters, the lead-in sweep angle to 0, and we'll go OK. So I think we're good here. Let's just do a little simulation. We're going to show the stock material and play. So we're doing the boring. I'm going to skip through that. Then we're doing the helical entry for all those bearing holes. Then we're coming back and doing the contour for that. Then we clean this up, okay, like we talked about before, at multiple depths. So yes, we are diving, but not very much at all, so we should be okay on the end mill. What I am concerned about is not this, but the contour after, so let me skip past that. Let's take a look at what the contour looks like. I think we're okay. We're really not diving into much. I think we'll be all right there. Then we go back and do the contour with the ramped entry. So we're slowly ramping at that 2 degree ramp, and we're just continuing to ramp again all the way down until we get down to the height that we want, which is 3 thousandths above the bottom. And then it leaves those tabs at the bottom. So I think we're good there. I'm gonna go close. Notice there is a little green check mark, or a little check mark. It's a warning. Let's go right click and show log. So the lead out is dropped. So we changed the lead in sweep angle to 0, and so that means the lead out for some reason was dropped, and so it just is going straight up. I don't think that's a problem, so we're just going to leave things like that. There is setup 2. So we have setup 1 and setup 2. I think that's it for the G-code, or for the tool paths.